in your opinion, what is an urban heat island? If we look at this figure, an urban heat island occurring in an urban area is triggered by high urban density in urban centers, which means how tall buildings are and how compact they are within certain plots of land. The other most important thing is regarding construction materials, whether they are rougher or pervious. The other parameter could be the building program, whether office buildings or domestic buildings, without forgetting population density and the impact that could bring. So usually in city centers we got nice mix of buildings. So it means office buildings cohabiting with retail buildings and housing. We got both compact and high-rise buildings. We got high population density, high amount of transportation networks, and so on and so forth. All these factors trigger temperature increases within the city centers. How? Through buildings, people, transportation, and also through the industry sector. And as we have started earlier, the nature of construction materials, whether rough or pervious, and how tall and compact buildings are. So, in terms of urban heat island, we observe substantial temperature shifts in city centers, especially in late afternoons and early evenings, and the shift can go up to 10 degrees or so. In these specific periods of time during the day, we observe temperature changes in the centers versus the outskirts of urban areas. And if we estimate the temperature difference between these two types of locations, we will come up with temperature differences, call it delta T, and this delta T, what we call the urban heat island intensity. So now, let's explain what's going on regarding these heat islands. As we have said it earlier, the fact we got compact and tall buildings, this entails a change of the terrain topography that makes a lot of effect on the airflow from a mechanical perspective. And then the other factor is about the nature of construction materials and how they react to irradiation. So we mean their ability to reflect on one side and then to absorb and to emit solar irradiation on the other side. So just talking about these two parameters, along with the number of people living in the city centers and the type of appliances they are using at home and at work, along with the type of the vehicles they are using, whether public transports or private cars. So, in urban centers, buildings act differently to irradiation because they have the capacity to absorb a lot of heat due to the amount of building volumes and envelopes. And they also tend to release a lot of heat and to release it in that period of late afternoons when air temperatures remain higher than the urban outskirts. So, on another question, in your opinion, what are the different heat transfer processes? So the first heat transfer mode is convection. So convection is a heat transfer mode that occurs within fluids, such as water and air. The second heat transfer mode or type is conduction. And this type of heat transfer occurs within solids like bricks and stones. And regarding the last heat transfer mode is related to irradiation, and this could even happen in a gap. And this mode is shaped by the behavior of electromagnetic waves. So as you know, most of the universal laws in physics are based on conservation and equilibrium. Well, here we are talking about the equilibrium and the balance. So heat balance or energy balance reflect a balance between the three types of heat transfer. Therefore, it is a balance between convection, conduction, and irradiation. Along the same lines, the heat balance occurs in urban areas, and we call it the urban energy balance. So now, here is the equation you have, and that explains the urban surface energy balance within urban settings. So let's explain the different terms. Q star is the term related to irradiation, is the result of incoming and outgoing irradiation. The second term is the anthropogenic heat. To clarify this, we could name it man-made heat otherwise, and usually it refers to wasted heat from human metabolism, transportation, buildings, and the industry. Now the third term, QH, is the sensible heat flux. It is a convective heat flux that occurs in fluids by affecting changes in environmental temperatures. The fourth term, scientists call it latent heat. And why the term latent? Because it is a convective heat flux that occurs without involving environmental temperature changes. It occurs mainly within green and water surfaces through processes such as evaporation and trans-evaporation. And of course, sensible heat fluxes occurs widely in hard and heavyweight surfaces like concrete and asphalt ones. So the fifth term, delta QS, is a term that explains conduction-related heat process within urban areas. So conduction inside building envelopes between outside and inside the building facets, and also in the ground and the building roofs. So we can relate the term of irradiance with the term of conduction. So here Q star and QS in urban areas as most of the exposed surfaces to solar irradiance are the horizontal ones. So of course, because they are so exposed, there could be an important ongoing heat conduction process occurring in this type of surfaces. Then the sixth term, called delta QA, is just the heat advected via convection in the atmosphere from an urban location to another, or from a sink to another. And the final term S reflects all other sources and sinks that a city might have. So what is the urban energy balance? Is the balance between irradiation and man-made terms on one hand, and sensible latent and advected heat and heat conduction on the other hand. Here we have a figure explaining the urban heat balance. So in the bottom atmosphere sublayer we have incoming irradiation, incoming anthropogenic heat in blue and orange colors respectively. And we have sensible and latent heat fluxes in red and green colors respectively. And then we have conduction happening in and out of buildings and the ground along with the advected heat.